Sometimes you'd like to find the equation of a linear function relative to a different function. There are a couple of important properties that are very similar to each other, or that have special relationships when we're talking about linear functions. One relationship that we often see and talk about is called parallel lines. Here's an example of a set of parallel lines. They lie side by side like this. From a mathematical and they never cross. From a mathematical perspective, notice that each of these lines has exactly the same steepness, which is why they would never end up ever intersecting or crossing each other. The same steepness means that these particular equations would have the same slope. So if we look at a problem here like problem 18, it asks us to write an equation in slope-intercept form for a linear function which is parallel to the line y equals 1/3 x plus 6, but goes through a different point. So if we want to try to identify the equation of a line in y equals mx plus b form, which is our slope-intercept form, notice that we need to identify the slope and the y-intercept. We are not given either of these pieces of information. We don't have 2 points, so we can't calculate the slope that way. What we do have, however, is a line that is parallel to the line that I'm interested in coming up with. So what I need to do is find the equation of this line here, the y equals negative 1/3 x plus 6. And because it's parallel, then the new line that I want is going to have the same exact slope. Because the y is by itself, the slope is real easy to pick out. It's just the coefficient in front of the x. So in this case, my parallel line has a slope of negative 1/3. So the line I want also will have a slope of negative 1/3. So now I want to come up with the y equals mx plus b equation. I want my slope to be negative 1/3 still, because if it's parallel, it has the same slope. And this time I do not know the y-intercept. So that's the next thing that I need to find. In order to find the y-intercept, we need an x and a y point, and we want to make sure that our new line goes through this other point over here, which is not a solution to the original equation that they gave us. So over here, I'm going to put 2 in for x and 1 in for y. So I end up with 1 equals negative 1/3 times 2 plus b, and now I need to solve this equation for b. As always, I'll be able to combine these numbers here. Negative 1/3 times 2 is going to give me a negative 2/3 plus b, and then I just need to add 2/3 to each side. Keep in mind, if we're getting a common denominator here, this would be 3/3 plus 2/3, which would give me 5/3 as my solution for b. So now that I have the slope, I have the y-intercept, I can now write the equation of the line, and I end up with y equals negative 1/3 x plus 5/3, and notice that this equation, make that 3 a little bit more clear there, maybe. Try that. Okay, in this case, y equals negative 1/3 x plus 5/3. It has the same slope as this line, so they're parallel, but it has different y-intercepts. So that gives us the information that we need. Another relationship besides parallel that two lines have that's kind of a special cool one is called perpendicular. Perpendicular means that your two lines cross at right angles. So suppose that I have a line that goes like this. If I want a line that crosses at a right angle, it's going to come down in this sort of a fashion here, so that we end up with that perfect corner where those two lines intersect. Now, obviously, these don't have the same slope at all. In fact, one is increasing and the other is decreasing. So in terms of our slope, the slopes have opposite signs. One would be positive and one would be negative. However, there's another piece of information too, and that is that the relationships of the slopes are not just opposite signs, but they are reciprocals of each other as well. So, for example, so we often call this negative reciprocals because they change the signs as well as flip the fractions. So, for example, if one line had, or if one equation had a slope of 2/3, then its perpendicular line would have a slope of negative 3/2. You switch the sign of it and you flip the direction. If we had an equation of a line that had a slope of -2, then its perpendicular line, think of this as 2 over 1, would be the opposite sign. So this time it would be positive, and then you'd flip it over. So 1/2 and -2 over 1 are negative reciprocals of each other. So that's the special relationship that we have when we're dealing with perpendicular slopes. So let's use that information to try to answer question 19. Question 19 is asking us to find the equation of a line in slope-intercept form which is perpendicular to the line y equals 2/5 x minus 1, and then goes through this specific point. So this particular line is in the y equals mx plus b form, so we can identify the slope very quickly as 2/5. Now the problem is this time I don't want a parallel line that would have the same slope. I want a perpendicular line. So my line should have a slope that is the opposite sign. So this was positive, so my slope will be negative, and then the flip or reciprocal of the 2/5, which would be 5 over 2. So this is going to be the slope of my line. Then I know that this line needs to go through the point 1, -4 in order to come up with the equation that I'm looking for here. So how do we find that? If I know the slope, we go to y equals mx plus b. My line, using the perpendicular information, gives me a slope of -5/2. And now I can use the x and y coordinates from the point that I was given to solve for the y-intercept, which I need to write my equation. So here my y-intercept is, or my y value, excuse me, is -4. My x value is +1. So I've rewritten my equation using a known solution to the function. Now I can always multiply this. -5/2 times 1, of course, is still -5/2. And then I can add 5/2 to both sides to get the b by itself. Common denominator again means we're going to have -8/2 plus 5/2, which will end up with a -3/2 overall for my b value. And then don't forget the final step, which is to go back and rewrite that equation in the y equals mx plus b form. Y equals, my slope was the -5/2 x, plus my y-intercept was a -3/2, so I can just write that as -3/2. And this would be the equation of a line perpendicular to 2/5 x minus 1, but that also goes through the point 1, -4.